All right, welcome to the explainer. So let me ask you something. Have you ever tried to draw a perfect circle, freehand, and instead you ended up with something that looks, well, more like a wobbly potato? Yeah, me too. Today, we're going to unlock the secrets of geometrical construction. Think of it as the simple blueprint that lets you draw anything with absolute perfect precision. So, to really get our heads around this, let's start with something super familiar: Legos. We all know how it works, right? You've got your bricks, you've got the instructions. But what happens if you miss just one little step, or you stick a piece in the wrong spot? The whole thing just doesn't quite fit together. Your epic spaceship ends up looking a little, well, wobbly. Sound familiar? Well, that is exactly what geometrical construction is all about. Seriously, forget all those scary, complicated math formulas for a second. At its core, it's just like that Lego instruction manual, but for drawing our world. It gives us the basic pieces and the simple rules we need to build with them perfectly. All right, so every great building kit has to have its essential pieces, right? So let's go ahead and unbox our new geometry kit and see exactly what we've got to work with. Okay, first up, the absolute bedrock of our entire kit: lines and angles. These are our most basic bricks, just the straight lines and the corners they make. And think about it, just look around you right now. The edge of your screen, the corner of the room, they are, and I mean this literally, everywhere.
And this is where these simple lines get really, really powerful. You see, they can either run parallel to each other, like train tracks that go on forever and ever without touching, or they can be perpendicular, crossing at a perfect 90-degree angle. And that one simple difference, it forms the basic skeleton for pretty much every building, every room, every design you can possibly imagine.
Okay, moving on to the next piece in our kit, and this one is a real superstar: the triangle. I know, it looks simple enough, right? Just 3 sides, 3 corners. But trust me, what makes this shape so incredibly special isn't how it looks, it's what it can actually do. And would you just look at the variety we have here? It's amazing. You can sort them by the length of their sides, like an equilateral triangle where every side is exactly the same. Or you could classify them by their angles, like a right-angled triangle with that perfect, crisp 90-degree corner. Each one is like a specialized tool in your toolbox, designed for a totally different job. So why do we care so much about triangles? Here's the deal. They are unbelievably strong. Think about it. If you push on the corner of a square, it just squishes and becomes a diamond shape, right? But try pushing on a triangle. It holds its shape. That's because it's incredible at distributing force down its sides. And that's why engineers use them for everything from supporting massive bridges to holding up the very roof over your head. This simple little shape is an absolute powerhouse. All right, we've talked a lot about straight lines. Let's switch gears for a second and talk about something a little more curvy. I'm talking about circles and arcs. These are the pieces that let us create those smooth, flowing designs. The perfect curves you can only really get by using a compass. What's so cool about a circle is that every single part of it is mathematically perfect. The distance from the very center to any point on the edge, what we call the radius, is always the same. And it's this perfection that makes them absolutely crucial for designing anything that spins or turns. Think about the wheels on your car, or the gears in a watch, or even just the face of a clock. Okay, on to the final pieces in our little kit: polygons. Now, that might sound like a fancy word, but it's really not. It's just a name for any shape that has a bunch of straight sides. So a square is a polygon, a pentagon with 5 sides is a polygon, a hexagon with 6 sides. You get the idea. And I'll warn you, once you start thinking about them, you will start seeing these things absolutely everywhere. From the perfect hexagonal pattern in a honeycomb to the square tiles on your kitchen floor. Polygons are basically nature's and our favorite way to create amazing, beautiful, repeating patterns. Okay, so we've got all our pieces laid out. But just like we said with the Legos, having all the bricks is really only half the battle, isn't it? Now we need the instruction manual. We need the golden rules that are going to make everything click together perfectly. And listen, these 4 rules, they are totally non-negotiable. First up is accuracy. No guessing. Close enough is not going to cut it here. Second, use your tools properly. That's what a ruler and compass are for, right? Third, neatness. A clean, clear drawing helps you avoid making silly mistakes. And last, but definitely not least, follow the steps. There's a sequence for a reason. If you try to skip ahead, you're just going to mess up the whole thing. So, pieces, check. Rules, check.
You know what that means? It's time to put all this into practice and see how it actually comes together. Let's try our very first build.
And this is that aha moment. This is where it all clicks into place. Just watch how we build this triangle. First, we start with a straight line. That's our base piece. Then we grab our compass and draw these two little arcs. That's another one of our key pieces. And see right where those two arcs cross? Bam! That's the third point of our triangle. It's almost like magic, isn't it? We used our pieces, we followed the rules, and we got a perfect, predictable result. And you can do this every single time. All right, let's wrap all this up. We're going to put everything together into one final blueprint, like a quick reference guide so you can remember everything that's in your new geometrical construction kit. And to make this super easy to remember, I've got a fantastic little memory tip for you. All you have to remember are these letters: LTCP plus ATNS. I know, sounds weird, but stick with me. And here's what that all means, broken down nice and simple. On one side, you've got your shapes, your pieces. L for lines and angles, T for triangles, C for circles and arcs, and P for polygons. And on the other side, you've got your rules, your instructions. A for accuracy, T for tools, N for neatness, and S for steps. That's it. That's your entire geometrical construction kit, all in one place. And really, that's the big takeaway from all of this. You're now officially equipped. You've gone from just kind of guessing and hoping for the best to actually knowing. You now have the fundamental blueprint for drawing pretty much anything you can imagine and doing it with total precision. So that's our explainer on geometrical construction. We've basically handed you the tools and the official rulebook. So we're going to leave you with one last question to think about. Now that you have the blueprint, what are you going to build?